Not all 3D features are created from sketch geometry. Applied features are added to a model based on the existing 3D geometry that's already been created up to that point. This means that these features modify the geometry in some way, and often have numerical values defining their size. The 4 applied features I'll focus on in this lesson are fillets, chamfers, the shell command, and the draft command. Fillets replace sharp edges with rounded corners of a specific radius. Chamfers replace edges with an angled face at a specified size. The shell command hollows out a part and keeps a specified wall thickness. And the draft command takes certain faces and angles them inward or outward by a specific amount of degrees. In this lesson, I'll walk through how to create each of these and how they modify the part geometry in different ways, depending on the settings used in each command. If I wanted to remove this flat area, I can replace both fillets with a single full round fillet. To swap this out, I'll edit the fillet feature and change the option to full round. Since a full round fillet eliminates one of the faces between 2 other faces, I'll need to select all 3 faces and click OK. Now the radius for each fillet is automatically determined by the geometry, and the flat face is removed from the top of the cylinder. Not only can fillets be used to round off edges to remove material, they can be added as transitions along an edge that adds material as well. For example, if I enable the fillet command, this time by accessing the shortcut menu using the S key, and select this edge that connects the cylinder with the top face of the block below it. The preview shows that material is being added between them. I'll set the radius value to 2 mm and click OK. Chamfers are another feature that's similar to fillets. Chamfers create an angled face along an edge as opposed to a rounded face created by a fillet. Chamfers are often used to break sharp edges as well, but they provide a different aesthetic and are typically easier to manufacture. One function of chamfers is creating a locating feature for objects to slide within a cylindrical hole. This means I want to change the top of this cylinder from having a rounded top face to having a flat face with a chamfer along the inner edge. Instead of deleting this fillet feature and creating a new chamfer, I want to point out that they can be swapped out interchangeably using the super feature functionality. To swap them, I can simply edit the fillet feature in the Design Manager, then click on the arrow at the top and switch it to chamfer. I'll clear both edges from the selection box, and then click on the inner edge. Notice the preview has a sort of funneling effect created by the angled face of the chamfer. This is what I'm looking for to create this locating feature in the cylinder. There are 3 different chamfer types to choose from. There's distance angle, distance, and symmetric. I'll go over them in this order. The distance angle chamfer type is determined by setting the distance away from an edge and then choosing an angle that extends through the material from that distance. For example, if I set the distance to 1.5 mm and choose an angle of 30 degrees, you can see that the chamfer is beginning 1.5 mm down into the cylindrical hole and then extending up and outward 30 degrees. If this isn't the exact geometry you're looking for, you can click the reverse direction button here, and the dimensions will change to reference the other face that creates the edge. Now the chamfer begins 1.5 mm away from the edge along the top face, and the 30-degree angle extends inward toward the center of the hole. The distance chamfer is instead determined by 2 distances away from the selected edge. So if I want the chamfer to begin 1.5 mm down from the top edge and 0.5 mm outward from the edge on the top face, those values can be entered here to create that chamfer geometry. And of course, you can always reverse the directions to change the orientation of the chamfer. The third option, symmetric, creates a chamfer with the distances being equal on both sides. Notice there's only one distance value to be entered. This is because this chamfer type automatically sets the distances in both directions to this single value. So if I enter a distance of 1 millimeter, the chamfer starts 1 millimeter from the edge on the top face and the inner cylindrical face. This preview looks good, so I'll click OK. And all the fillets and chamfers I was looking for have been added to the design. Now that you've seen how to add fillets and chamfers to parts, which are both applied features, I'd like to take a look at two more applied features, the shell command and the draft command. The shell command takes solid geometry and hollows it out, leaving a wall thickness of specified size. This is most often used to create injection molded plastic parts, which are usually designed to have a thin wall throughout the design. However, the shell command can be used in many different situations. The shell command can be enabled from the Features tab in the action bar shown here. There are a few ways you can shell a part, using an inwards shell, an outwards shell, or adding thickness in both directions. I'll use the inwards option for now and show you the other two in just a bit. The most common way to shell a part is to select a face that would be removed, and then the wall thickness is applied to the remaining exterior faces. For instance, if I select this bottom face of the block to remove it, you can see the preview showing a wall thickness being added inward from the exterior faces that remain. To help make this easier to see, I'll set the wall thickness value to 0.5 millimeters and click OK. You can see as I rotate the part that the bottom face has been removed and the part is hollowed out up until the wall thickness added on the inside of the exterior faces. This occurs for all the flat faces, the cylindrical faces, and even the fillets and chamfers. To show you the other shell options, I'll edit the feature once again. For now, I'll keep the thickness the same. However, if I change the shell option to outwards, the preview updates to show that the wall thickness is being added on the outside of the exterior faces. This means that the geometry I created before the shell feature is being entirely removed, creating the cavity inside the part. If I change the option to both, that same wall thickness value is added on the inside and outside of the exterior faces. This means the wall thickness is doubled, in this case totaling to 1 millimeter. Notice there's also this shell body option. This can be used to hollow out the part without removing any of the faces. So if I switch the shell option back to inwards and turn the option on, you'll see in the preview that the bottom face has a wall thickness being added as well. So if I click OK, the bottom face remains and the part is hollowed out with all the exterior faces kept in place. You can see this more easily if I go to the View tab and enable shading with edges and hidden edges. For now, I'll edit the feature again and remove the bottom face with an inward shell. The last applied feature I'd like to show you is the draft command. The draft command takes flat or cylindrical faces on a model and angles them outward or inward relative to what's considered the neutral plane. This feature is also often used in injection molded plastic parts, as the side walls of the design have a slight angle added to allow the part to be pulled out of the mold block. There are also many other scenarios that using this command is useful for. Before I use the draft feature, I'll roll the Design Manager back before the shell command and the fillet and chamfer, which will allow me to apply all of them after I add the draft to the part. The draft command can be enabled here in the Feature tab of the action bar. If the bottom face of the part is going to be shelled out like I had done, an injection molded part would need to have the neutral plane be parallel to that face for this design to be ejected from the mold. This means these side faces of the block and the cylinder should be drafted. For the first selection, I'll choose the top flat face of the cylinder as the neutral entity, and then choose the outer cylindrical face and the outer faces of the block. And for now, I'll set the draft angle to be 5 degrees. This makes a more trapezoidal shape on the block, and the cylinder angles outward as well. Now that the draft is applied, I can move the Design Manager to the end of the features to include them all.